Hi everyone, welcome to our webinar, Basin and Petroleum System Modeling. Developer in Reservoir Solutions Company. I will be pleased to be the coordinator for this webinar with our brilliant instructor, Dr. Tamer Salim. So just we will have 5 minutes presentation about Reservoir Solutions. Reservoir Solutions is a company specialized in providing technical studies and courses for oil and gas companies and professionals. The company incorporates many professionals with diverse technical background related to oil and gas exploration and production. Our services include technical reservoir studies, field development planning, reservoir static and dynamic modeling, economic feasibility studies, technical support for academic researchers like PhD and master degrees, assisting in writing technical papers and publishing, technical petroleum courses by industry expertise, and we are providing mentorship programs. For our today webinar, our instructor, Dr. Tamer Salim. Dr. Tamer Salim is a General Assistant Manager for Geology Department in Khalda Petroleum Company, which is DB with Apache Corporation in Egypt. He has more than 18 years of experience related to basin modeling, petroleum system identification, and exploration activities. He has a PhD in geochemistry and geomechanics. As usual, for our webinar rules, if you have any questions, you are free to put your question into the Zoom chat, and our instructor will answer your question at the end of the session. Please mute your camera and microphone. In case that you wanted to have a webinar certificate for the attendance, you can fill into the form that will be sent into the Zoom chat at the end of our session. For upcoming web events and courses, you can join our Telegram channel, or you can subscribe to our YouTube channel, or you can follow our LinkedIn page. And the link is it will be sent into the Zoom chat. You can contact us via the email and the WhatsApp. So thank you all and hope you nice session, inshallah. So Dr. Salim, you can start, please.
Hello, Sir Abdullah, are you hearing me?
Yes, I'm hearing you. You can start.
Yeah, yes, okay. Yeah, the screen is shared, okay?
Yes, it's shared, yes, but you
Yeah,
have just to
okay,
click the
okay,
platform.
okay. Thank you for very much, Mr. Abdullah, for your dedication. And thank you, and special thanks for all the reservoir solution team. And thank you for all my audience for being here in our webinar. Today, we will talk about the fundamentals of basin and petroleum system modeling.
Sorry, sir, if you can make your presentation onto the presentation mode.
Yes, okay, thanks. Okay, again, today we are talking about the fundamentals of basin and petroleum system modeling.
Sorry, sir, we have a black box into the right of the, yeah,
Also, again,
no,
we solved that again before.
no. Okay, if you can stop share and share again.
Yes.
You can stop share and share again.
Okay. It's okay now?
Okay. Yes,
Okay?
yeah, thank you. You can stop.
Yeah,
Yes,
okay.
you can stop. Thank you.
So sorry. I'm so sorry for interruption. Okay. Today we're going to talking about the fundamentals of basin and petroleum system modeling. The agenda of today, inshallah, we are talking about firstly, what is the petroleum system? What is the petroleum system, and what is the petroleum system is composed from composition of petroleum system. The petroleum system are composed from elements, main elements, as all of us know, and the process of the petroleum system also. Elements of petroleum system as the source rock, reservoir, seal, and overburden, and also the process of element of petroleum system like maturation, generation, expulsion, and trap formation. After that, we will talking about the petroleum system in industry. After that, basin modeling assessment, how we can assess the basin modeling, and the basin modeling input, what is the main mandatory inputs for building the basin modeling, and finally we will run some things to calibrate, and some tips for calibrate and validating our calibration, our model. Okay. As you know, the success of any exploration campaign depends on the convergence of crucial geological elements and process, which is called the petroleum system. Basin and petroleum system modeling allows geoscientists to examine the dynamics of sedimentary basin and their associated fluids to determine if the paleo condition were suitable to fill the potential reservoir and be preserved in there. The petroleum system encompasses of a pod of active source rock, and its related oil and gas, and includes all the essential elements and the process needed for oil and gas accumulation to exist. The essential elements are the source rock, reservoir rock, seal rock, and overburden rock, and also the process, which includes the trap formation, hydrocarbon generation, migration, accumulation of petroleum. But all the essential elements must be placed in time and space to get the critical time to fill the petroleum system with hydrocarbon. What is the petroleum system? Petroleum system, as we said, is a pod of active source rock, including the essential elements and also essential process. The first element of the petroleum source rock is the source rock. What is the source rock? Source rock is a unit containing sufficient organic matter with a suitable composition, which is called the kerogen, to uh, biogenically or thermally generated and expelled petroleum. So we need organic matter with a suitable composition which is the kerogen composition under condition of temperature and a long time period, which is important to generate and expel the hydrocarbon from the source rock. The second element of the source rock is the reservoir rock. What is the reservoir rock? All of us know what is the reservoir rock, but we need to focus on the reservoir rock that should have a sufficient porosity and permeability to sustain the hydrocarbon which are migrated to the reservoir and allows to passage the hydrocarbons through the production process after that. Okay, the third elements of the petroleum system is seal. Seal, shale or other impervious rock that acts as a barrier to the passage of petroleum migration in the subsurface. It overlies the reservoir rock to form the trap. Also, the seal rock known as the cap rock. The fourth element of the petroleum system is the overburden rock. The overburden rock, all of the geological column of the overburden above the source rock considered as overburden rock and helps in increasing the temperature and the pressure, which helps in the maturation and aid and play an important role to the source rock to be matured and expel the general hydrocarbon and generate after that. Okay. The hydrocarbon petroleum system process of the elements. So as we said, there are four important elements of petroleum system, and there are also a process of hydrocarbon. The process of hydrocarbon includes the hydrocarbon generation. Firstly, the hydrocarbon maturation. Now we have a source rock, but to get hydrocarbon from the source rock, we should be matured, and after that, the kerogen after maturation and the transformation from the solid state to hydrocarbon should be generated and should be expelled and should be migrated to the reservoir, and also the accumulation. How it's an important process to get a petroleum system success. It's should be the hydrocarbon be accumulated and deposited in the trap formation. Yes, the migration is divided into four categories. Migration, after the cracking and generating after maturation and generation of hydrocarbon should be migrated from the source rock to the reservoir rocks. It's divided into four categories. Firstly, the primary migration is a process of loss of hydrocarbon of oil and gas molecules out of the source rock itself. Okay, the primary migration is the movement of hydrocarbon through the source rock. After that, the secondary migration is the movement of oil and gas that generated and leaving and starting leaving the source rock through the porous carrier to the reservoir rocks. What are the third category? The third category of the third type of migration is the tertiary migration. It's the migration to the surface, either from the reservoir or source rock, and which is called this migration, or the hydrocarbon in this case it destroyed. Okay. The remigration, the fourth type is the remigration. It's a migration of from one reservoir system position through an intervening section into another reservoir position. From its remigration from trap to another trap. Okay. After that, the accumulation of hydrocarbon. The volume of hydrocarbon migrated into a trap, if it faster than the trap leaks, resulting in accumulation. So we will find the accumulation of hydrocarbon in the reservoirs. The element of petroleum system is the reservoir rock. Reservoir rock, as we said, should have a porosity and permeability. Okay, should have enough porosity and permeability, and that is the third elements of source of petroleum system is the seal rock. Seal rock is an essential element of the petroleum system. Oil and gas, it's the basic of shale rocks, basic concept in this topic, that oil and gas are less dense than water. As we said, all the three phases of fluid are found in the trap. Oil, after that water, above the water, oil, and after that the gas. All the oil and the gas are less dense than water, so they migrate from the source rock and tend to rise from high pressure to lower pressure within the sedimentary rock column. Okay, the petroleum fluids will continue to rise under buoyancy effect until they reach a seal. After that, it will continue if the seal is found. Is the seal is found, so it will inhibit the movement of and the hydrocarbon from movement to rise up. So shale or other impervious rock that acts as a barrier to the passage of petroleum migrating in the subsurface. It overlies the reservoir rocks. Okay, seal rock might be shale or massive or impermeable rock like crystalline rocks like carbonate. But it should be fine grained or massive to inhibit the petroleum hydrocarbon from escaping to above to the surface. Now we are talking about the petroleum system in industry. What is the petroleum system? As we said, it's an integration of the structural and the stratigraphic framework with a description of basin fluids to understand how the basin came to be. Why is it? كيف how is the petroleum system came to be the way is it? Petroleum system integration, it's an integration of geology and geochemistry, and finally the basin modeling. Why we integrate this? It's a question now. Why we integrate all of these parameters? The integration will provide us with a holistic understanding of how the basin fluid system works from source rock, is the first unit of petroleum system, until reservoir, until to the final stage of refinery. And also the integration will give us more robust and logical solution, allows more effective exploiting of technology into petroleum industry. And finally, the integration make all pieces of the puzzle fit together. So it's a petroleum system in industry. It should be an integration of geology, geochemistry, and basin modeling. Now, the first one of the integration is the geology. If we started with observing the surface structure geology, as we said here. After that, making the acquisition and getting the 2D or 3D or 4D seismic data. After that, making an interpretation to determine the main horizons, and determining the formation tops, and now we are talking to laser point. So after getting after interpreting the seismic and getting the horizons of the reservoir and our source rock and getting after that the structure map, getting structure map for our interested zones, okay, and determining where might be the hydrocarbon potentially are found, and getting the structure map and for the source rock and reservoirs. After that, we make fishes maps for after drilling and getting more information from about the all the horizons of the subsurface. We trying to make fishes maps and like this in models and distribute the fishes of through the interested zones which is, might be source rock or reservoir, and after that making the porosity and permeability for porosity and permeability for source rock for our interested reservoir rocks. Okay, and after with after that we integrate all of this data which we have to make a correlation between the drilled wells and getting the final geological data input in the model. So the first one of integration is the geology. The geology will we will get from this step all the data about thickness of formation, depth of our interested zone, formation tops, the composition, the facies and the lithologic composition, the porosity, if we take a core or sidewall core to making like this tests, erosion depth and erosion thickness, and finally the age of all of these horizons. Okay, the second one of integration is geochemistry. The geochemistry, geochemical analysis involves studying the chemical composition and properties of rock and fluids. Okay, the geochemistry including the geochemical study of rocks and fluids. The geochemical study we focus on focusing in to analyzing the organic matter of the rocks, which and after that the organic matter of rocks we can after we determine if this a source rock and asking us about the geochemical the organic matter if it's present or not or none. So we if it present, so we'll need to determine what is the quantity of organic matter and what is the quality. The quantity of organic matter by determining the quantity of total organic carbon rich in STOC measurements by LICO or by rock eval pyrolysis, and after that the quality. If we need to know the quality of organic matter, we need to run the rock eval pyrolysis and getting some important information about the source rock like S1 and S2 and S3, which helps in hydrocarbon in determining the hydrocarbon generation and the potentiality of the source rock. And also we get the hydrogen index and oxygen index, which can be simply calculated from dividing the S2 and S3 on the TOC to getting the hydrogen index and oxygen index, which are formed in Van Cleveland diagram to determine the kerogen type and the type of hydrocarbon, and also the quality. From the rock eval pyrolysis we can get the Tmax, which is maximum temperature and at the peak of S2, which and also by determining the vitrinite reflectance, which help us to determine the thermal maturity and accurate determinations on the timing of generation. So the rock study, the geochemistry focusing on rock to determine the quality and the quantity of organic matter. And also not geochemistry not focusing on rocks only, but also it focusing on the fluid through in the source rock, the fluids and sorcerer, and determine and the measurement of the and determine the distribution of biomarkers through the GEC or gas chromatography test or gas chromatography mass spectrometry to the sample which is from source rock and extracting the S1 value which is called the bitumen, and run the gas chromatography, and might be the a sample from the reservoir itself to oil hydrocarbon from the reservoir itself, and running the gas chromatography and the gas chromatography mass spectrometry to get an information about the fluids through the source rock, or which come from the source rock. The biomarkers provide us with important data about the fishes and the environmental indicator, like all of these parameters. C27 strains, algae input, and marine indicator. It helps to define accurately the deposition of environment, and also C29 strain terrestrial indicator. Homohoban increase with marine environment. C29 norhoban, marker of some carbonates. So and also C30 olenian, marker of higher land plants. And also the gas biomarkers data can help us in as a maturity indicator, like C21 and C22 strains increase with maturity, and also the C30 dihoban increase with thermal maturity. And finally, the TS divided by TM over TM increase with maturation level. Also, we can get some information about the age indicator from the biomarkers like C30 olenian. It's only found in the higher plants, which is might be late Cretaceous or tertiary. Okay, the source rock. Source rock, it's the first element of the petroleum system, which is the main unit cell to get a petroleum system, which we will firstly search. We are search for the presence of source rock. And trying to know the quality and the quantity of source rock, and which type of kerogen, and what is the extracted hydrocarbon from this kerogen. Source rock, we can define the source rock as sedimentary rocks that contain sufficient organic matter, as we said before, with of suitable composition to biologically or thermally generated. Source rock might be generated by biogenically at a shallow depths, or thermally to extract it, to cracking the kerogen to and to be ready to generate and expel hydrocarbon over the geological times. Okay. We will study now the type of source rock. There are many types of source rock based on their hydrocarbon potentiality. Can divide it into effective source rock. The effective source rock is containing organic matter with a sufficient quantity, okay, and able to generate and expel hydrocarbon. If it potential source rock, if it increases thermal maturity, so it need thermal maturity, increasing thermal maturity to be an effective source rock. What is the second type of source rock? It's the effective source rock, and that is what we need through our study. Is the effective source rock, the source rock containing organic matter presented, generated, and exhibiting hydrocarbon from with a commercial accumulation. So what we need in petroleum system? The effective. We are searching about what? Searching about the effective source rock. After that, the relic effective source rock, it's an effective source rock, okay, but has ceased generating and exhibiting hydrocarbon, might be by due to thermal cooling or uplifting. The fourth type of source rock, it's a spent source rock. Spent source rock, it's an effective source rock, but it has exhausted its ability to generate and exhibit hydrocarbon, maybe due to lack of sufficient organic matter. So we search in the source rock about sufficient organic matter, has quality, good quality, and has a condition of temperature and the pressure which make the source rock to generate and exhibit hydrocarbon. Okay, there are some types of source rock based on lithology. As we see in this picture, the source rock might be organic rich shales, might be carbonate source rock, or might be coal source rock. Yeah, I know. We are focusing on the studying of the source rock, than the other elements of petroleum system elements, because the source rock is it's an important the important one to as we said, the first unit cell to generate the Basin modeling. So we are talking about the organic matter average in the rock. Source rock are sedimentary rock, okay, that contain sufficient organic matter which capable to generating and exhibiting hydrocarbon. How much source rock in the source rock and organic matter in the earth? Yeah, we are very unfortunately, if we divided the rocks in the earth, we will find only 8% of the all of the wall of the crust is sedimentary rock. The sedimentary rock divided into shale and siltstone with 60%, and other limestone and sandstone with like this percentage. So our source rock might be, as we said, shale and siltstone, which is represent 60% of 80% of the sedimentary area of the earth of crust. Okay, the mineral. If we talk the shale and siltstone percent of from the source rock, we will find that 99% of the shale and siltstone rocks are mineral matters, but unfortunately 1% of them is organic matter. So we have one organic matter of 60% of shale and and siltstone, and not only, but of 80% of the sediment of the earth crust have the organic matter. Only we have 1% organic matter. Not only that, but this one of organic matter are divided to 90% kerogen and 1% bitumen. Bitumen that which is 10% is bitumen and 90% percent of kerogen. Bitumen, which it's the cracked oil from the kerogen that be able to migrate and transform to the move to the reservoir rocks, which are represented by the value of S1 in rock eval pyrolysis. Okay. Okay. This bitumen يعني okay 90% of one of the bitumen are resins and asphaltenes, and only 10% of are saturates and aromatics. Actually, really, we are very poor. Now, we will study the organic, the how to transform the organic matter into petroleum. The organic matter, which are after the organic matter deposited in the last cycle, as we said, with 1% of in the shale and siltstone, organic matter after deposition and deep burial, and having the after the deposition, the organic matter is deposited. After that, if it if it was lucky and have a deep burial and compacting and preservation from the effect of bacteria or oxidation, it will be preserved well. After that, the burial and the compaction after this stage, it will be by increasing the temperature and the pressure, it will passes through the diagenesis of the kerogen, and the diagenesis of kerogen passes through three types of diagenesis, starting from diagenesis at shallow depths and catagenesis. In this stage, that the oil start and reaching the peak and ended in the catagenesis, and after that the third stage of the genesis which is metagenesis, and ending of oil and starting in dry gas generation. After the stage 3, step 3, this hydrocarbon after deposition and after burial and compaction, and and after increasing time and temperature, it will be generated and expelled and migrated to the trap cycle step. After that, we need to focus on what is the time of trap formation. Is it composed or found after migration or before migration? Okay. If the trap and reservoir formation is founded before the migration, we are lucky. So the trap will collect the hydrocarbonate and accumulate it. After that, we transform it to the sixth step, which is exploration and production in what we need to do, and all the petroleum companies did in the world, around the world. Okay, as we said, the diagenesis of organic matter started with when animals and trees die. The organic matter is buried quickly in areas where there is no oxygen. The organic matter may be preserved and the petroleum may be formed. The chemical process, by increasing temperature and pressure, chemical process will take place in order to transform the organic matter preserved from the solid state in the source rock. It transforms the organic matter into a petroleum, which is called the cooking process. There are three phases of maturation to the kerogen. The first one is the diagenesis. The diagenesis, this occurs at a shallow surface, which is called the immature zone. There are no any generation of hydrocarbon except the biogenic methane, which is called which is occurred with the effect of biogenic activity, not thermal activity. After that, after the diagenesis, the catagenesis stage, it's by increasing the temperature, depth of burial, and temperature and the pressure, where there is no any bacteria living in this environment. The critical temperature at 60 Celsius, it is the start of oil generation, as we know here, start of generation, and reaching the peak of oil generation at 100 Celsius, which is equivalent to 212 Fahrenheit, and ended at 175 through the oil zone. So the catagenesis starting of oil and gas generation, the oil generation reaching starting with a low amount and increasing until reach the peak at this temperature and ended after that. But through this stage also, we can notice that the gas generation started with low amount of gas, and after that reached in the zone of at the last of the catagenesis zone, which is called wet gas zones. After 225 temperature, we entered the zone of metagenesis and the generating of dry gas zones. So yeah, now we are talking the integration of geology and the geochemistry and geochemical evaluation, and it is the third one of integration to of petroleum system, integration to build the petroleum system. As we to be remembered, the petroleum system in industry as integration of three important things: the geology, the geological information, after that geochemistry information, and the third one is the basin modeling. Okay, basin modeling is simulation. It's a simulation. Simulation combines the rock and the fluids to explain the basin history. And with the basin modeling, we're trying to find a solution to all our questions in the petroleum system. Basin and the petroleum system modeling approach allow geoscientists to examine the dynamic of sedimentary basins, the dynamic in the sedimentary basin, and their associated fluids, which is hydrocarbon, which might be oil or gas or three phases, and to determine the suitability of earlier conditions for hydrocarbon to fill and preserve potential reservoirs. Now, the basin modeling, which we are focusing on the basin modeling exercise. The basin modeling exercise to be assessed should be through four elements. Firstly, we need to know the burial history of the basin. To be assessed well, the basin modeling to be assessed well, we need to have the information about the burial history of the basin. Secondly, the thermal history of the basin. Third, the maturity history of the source rock. And finally, the expulsion, migration, and trapping hydrocarbons. Basin modeling is a term broadly applied to a group of geological disciplines that can be used to analyze the formation and evolution of sedimentary basin and the evolution of potential hydrocarbon reserve. Okay, basin modeling allow us to compute the thermal and subsidence history of the basin as a means of predicting the volume and distribution of petroleum as in a given area. Software like softwares which can run the basin modeling and can get accurate information about the basin modeling like Petromode, which are related to Schlumberger, and also the basin mode. Basin modeling, as we said, it's enable us with investigation and the combination of all the information to get an accurate answer about how what is the source rock, how if is the source rock is present. Okay, if it's present, how amounts the organic matter, and how about the how what is the quality of this organic matter, and what is the timing of maturation, what is the type of Kirjan type, what is the type of maturation, and if it matured and enabled to expel an hydrocarbon, how amount of hydrocarbon expelled from this source rock, and after the expelling, where how much the distance between of the migrated hydrocarbon. Is it settled in the reservoir reservoir trap, or the time is not helping us to sustain and collect and accumulate the hydrocarbon? Okay, the basin modeling, it will help us in all of these things. Okay, the basin modeling, as we said, we are talking about the burial history. The burial history of the model. The basic concept in geochemical modeling is to use the available data like stratigraphy, lithology, stratigraphic, how what is the depth of formation tops, layers, age of every layer, how much eroded sediments, how much the eroded sediments, and also what is the age of erosion. Burial history modeling also used to predict the timing of maturation and amount of hydrocarbon generation. And amount of hydrocarbon generation, not only, but determining the accurately the oil window and the onset of gas generation. We will see that in the after that in the slide, in the next slide. So the temperature and time play an important role in the basin modeling and to determine the timing and timing of hydrocarbon generation and explosion. It's an example of the burial history, and as I said in the previous slide, that we can determine the what is the depth and the corresponding time of all of these parameters. Early oil window, which has like this color, and starting in this depth, this age, and corresponding the depth, and also the main oil window starting in generation, okay, from here, and the late oil window, and finally the onset of gas generation and ending of oil generation. If we need to accurately determine which is for define or specific the source rock, which and say what if it enters the oil window or gas or not. Okay, we will follow the base, the bottom of this layer. We will, if we will talk like this formation, like this layer, okay, which is عالم الويب 2. We follow the bottom layer, okay, and see accurately how where it transacted with the our line of color. So this layer is entered the oil the late oil window at this age in the upper Cretaceous, and the corresponding time at like depths which might be 6,000. Okay, it's and this limits and boundary of maturity based on test. And this another example of the burial history and how it how can we read the burial history of the model after we build it, and how much it match our basin tectonics. Like in this like in this burial history we need like this arrows reflect the uplifting here and increasing the sedimentation rate, and these arrows reflect the maximum burial subsidence. It's subsidence and it's the maximum burial subsidence, and also we can say it with depth and also the time. Here we can say that the maximum elevation above the sea level it is in this area, and it's a time of this maximum elevation and also the depth. Okay, it's a very quiet tectonic, no any tectonic events here. It's basic, the all the basic sediments. Here it's a new basic sediments. It's so it's simply the basin, the burial history of the model, explain all the tectonic events that happen to the basin study through the basin from until from present from the first day until the present day. The thermal history. Thermal history modeling is the second stage of basin modeling assessment. To assess the thermal history, it's the second stage. It's the thermal history. Thermal history modeling, which builds on the history modeling, builds on the history modeling, as we see, like the burial history, but the overlying is temperature, and we can see the gradation from temperature. It's which this red cycle and this arrow reflects that the burial history is suffering from high temperature, reached to 155, and the blue circle reflects that low temperature valley history. The thermal analysis includes determining the present day heat flow and also value heat flow and the value water depth, surface water interface temperature, and thermal conductivity in order to determine the amount and the type of corrosion and timing of heating events. So the time and temperature plays a major role in the maturation of this of our basin. The thermal history, it's showing the temperature effect on our basin. How can calibrating the thermal history? It's the thermal history. It's most of uncertainty in this. There are many uncertainties in calibrating the thermal history. We can use the temperature data from logs after correcting the bottom hole temperature or any collected data from the logs. Also, we can use parameters such as source rock analysis, which is TOC, total organic carbon, and also from the rock eval pyrolysis data, we can get the Tmax. and the vitrinite reflectance, which is used as a fingerprint to calibrating the parameter, the thermal history of the model. And also, as we said, the biomarkers can help us to with some information about the maturity indicator. We'll talk about the corrected borehole temperature. After collecting the temperature from logs, we should make a correction. All of the reading of bottom hole temperature, whether it fine from well logs or DST or pressure test or production test, all of them have the same error. Should be corrected. Okay, this formula we can use it to correct the bottom hole temperature. Temperature true equals to temperature at the surface plus the function of f, which is equals the time since circulation multiplied by temperature, measured temperature at the bottom hole at the bottom minus the surface temperature minus 0.01391 multiplied by depth and minus 4489 98. Why we should make the correcting the bottom hole temperature? Because it might be related to the accuracy of measurements tool, or and to avoid the short static time without circulations. We in many situations we stop circulation, and it permits the hole to be build up in temperature again. And also the recirculation between measurements. Okay. So if we want to use bottom hole temperature, we should correct it before use it in calibrating the models. Also, the present day geothermal, the corrected temperature, we will collect the corrected temperature from all the drilling wells and making the geothermal gradient, and making like this map of geothermal gradient, which reflects the geothermal gradient. And as we see in this map, we can say that we have increasing in geothermal gradient in this position and also in this position, while the center position no high geothermal gradient. What does it mean, high geothermal gradient? High geothermal gradient, if it increase, so it will help in maturation. Used as we said, the maturation is a temperature and time. If we have a high temperature, so it will help in maturation. So if we have a geothermal gradient in the present day, it might be reflect that maturity in this area increased, and also this area also. The thermal maturity curve. If we wanted to calibrate the thermal maturity curve, the burial history, the thermal history, if we want to calibrate the thermal history, also we need to use the temperature in the modeling. Temperature, as we see, and it's a result of maturity curve from Petroleum. It's this a relation in depth between depth and temperature, and we can say that blue line is modeled data of it's modeled data, and this red cycles are the measured data. So if we can say that our models is well calibrated, we should have a great matching between the model data and also the measured data. Not only the thermal maturity curve, but also we use the vitrinite reflectance, which is considered as a fingerprint in calibrating our models and reflecting the maturity indicator. As thermal maturity, we have a vitrinite reflectance as maturity curve. We should got a matching between the modeled line and also the measured data of vitrinite reflectance, which used as a calibration to be validated. Also, the rock eval pyrolysis Tmax. Tmax we can also use as calibration of the model, and as in this plot, and also the total organic carbon used also as and to calibrating our model. The Basin modeling inputs. So now we are talking about the Basin modeling in assessing of Basin modeling. Now we are talking about the Basin modeling inputs. The Basin modeling inputs, we can say that there are a mandatory input to build the Basin modeling. First, the present day models, including horizons, phases, and faults. After that, age assignment or for all of the horizons and maps. After that, the paleogeometry. What is the paleogeometry? And if it is it matched between to our present day, or it's different? Paleogeometry including water depth maps, erosion maps, salt thickness maps, and the paleo thickness maps. And the fourth one is the boundary condition. Boundary condition, surface water interface temperature maps, and also the basal heat flow maps. The five inputs in the Basin modeling is phases. Phases. What is the definition of phases? Distribution of phases through our source rock or our reservoirs. Seismic optional attributes, cubes, maps, reference horizontal, but might be it will be optional to as input. The Basin modeling inputs like present day model. The present day model including the horizons. The horizon here, it's horizon, the upper horizon and the lower horizon, and the layer between of them, and the faces. What are the faces of this layer, which is might be source rock or reservoir, if it's contained from shale or sand or a composition of multi lithologies. Facies maps, and also the distribution of the facies maps through our layers and the fault surface. So we are talking about the present day model. After that, the age assignment. The age assignment, yeah, we can we need to accurately determine the age of the geological events. Age of geological events, which what is the time of start of deposition, and what is the end? What is the time of end of deposition, and what the thickness of these layers, and also how much eroded sediments. What is the age of starting eroded and finishing of eroded? We should make age assignments for all horizons and the layers and erosion and all and also for the fault start and end time of the fault, and determine which type of lithology and to get accurate information. The models, the third one of paleogeometry of model input is paleogeometry. Paleogeometry including water depth maps, erosion maps, salt thickness maps. Present day models can be built from measured such as seismic and well data, which while the paleo model is mainly based on today we can build a model with using the seismic and well data, but The paleo model is mainly based on knowledge and principles from historical and regional geology, sedimentology, and tectonics, which results in higher degree of uncertainty. So there are an uncertainty in building the paleogeometry. Water depth maps can also be derived from the already known distribution of sediment fish and vice versa. Okay, we can determine the surface water interface temperature by estimation by like in Petroleum mode. It's an automatically we can select the if what is the position of what's our position in the worldwide, and determine and type the latitude. Also, we can get surface water interface temperature to our basin. Okay. Validation of this chart is used to be calculate the paleo temperature of sediment water interface for sediment deposition at a latitude and age. How can I derive the water depth maps? How? If we don't want to use like this automatic surface water interface temperature, which is related to petroleum. It's we can derive it from the isostatic consideration of crustal stretching model together with assumption on global sea level changes. They describe the burial and uplift of the basin. The model input. It's a boundary condition. The boundary condition, surface water interface temperature. What is the surface water interface temperature? And what is the basal heat flow? In this image, we can say that is the sea level, and that's our basin. Okay, this is the sea level, and this is the sediment water interface temperature. Not here, but it's a difference between the surface temperature and the surface water interface temperature. It's a great difference between them. So it will be more accurate if we use the surface water interface temperature as a boundary condition as a main input in our model. To it will tell us about the temperature of the source rock, temperature of the layer, and how much the temperature that affecting our source rock, and what is the age of deposition. Okay, so that's surface water interface temperature. Okay, boundary condition, it need to be defined for heat, pressure, and fluid flow analysis through the entire simulated geological history. The usual boundary condition data for the heat flow analysis are temperature maps on the sediment surface or the sediment water interface and basal heat flow. What is that? What is the far distance between our source rock and the basement? As you know, the basement will affect with a high temperature on the source rock, and it might be destroy increase the maturity process in different if we compared it with a far distant source rock from the basement. So the paleo heat flow, the basal heat flow, it's important to calibrate the model. The model inputs, the 5, it's the facies definition. As we said, the facies definition and the facies distribution of the our layers, and the age of every, and the age of every facies. And also we can use TOC map and hydrogen index maps. Model calibration. As we said, the model should be calibrated by the boundary. By the most of them is the boundary condition, which including the paleo water depth, surface water interface temperature, and the basal heat flow. Okay, this the effect of lithology time. It is now we can ask a question: is it different if we all of if all the our lithology is shale or sandstone or carbonate? Is it make a difference during the maturity? Yes, it makes a great difference in maturity. So we need to be accurate while determining the phases and the lithology of our layers. Because every lithology has a different density and different porosity and fluid matrix. And also, every lithology has a different thermal conductivity. So if the heating is coming up from the basal heat flow, what are the media? What are the media of that transform this temperature from the basal heat flow until reaches the source rock? If it's shale, so what is the difference? The shale is containing radioactive materials and high porosity, and the most of lithology is high porosity. Most of porosity, the high is the most rock which which has high porosity but low permeability. Okay, so in this exercise we use we transformed all the layers or the layers here where instead of shale and sand and siltstone and other lithology, we transformed it and changed it to only shale rocks. Then now we can no, we can observe the distance between the model data and the measured data. Now we see a good matching between vitrinite reflectance here, the measured vitrinite reflectance and the model data. And after changing the most of lithology to shale, so we increase the maturity and the thermal conductivity of the media between the base heat flow and our source rock. So we can see that the modeled vitrinite reflectance is increased in the maturity, and now we can see a difference between the modeled line and the measured line. Okay, here. Now there are a great difference between if we have all of the media is shale or another different lithologies. That's the effect of changing lithology in vitrinite reflectance. And also we can say that that the same difference in temperature corrected pool temperature maturity curve. After changing the lithology from multi-lithology to shale to only lithology shale, now we here now know a good matching between the measured and the modeled data. Now there's a difference between the model temperature is increased, which reflects that the shale has an high thermal conductivity, which increasing the maturity in the which increasing the maturity. Okay. Now, sorry. After that, we will see the effect of erosion. How is the erosion has an effect of our maturity curve, maturity profile? Yes, it also has a great effect on maturity. Now, we say that a good matching between the models and the measured data. After increasing the making an entry of erosion, which is equal to with a low amount of erosion thickness, and we entered here a low amount of erosion thickness. We can say that there are a mild difference between the measured and model data. So the modeled line decreased in maturity and came towards the left. And if we increase the amount of erosion, so now we can see that the modeled data is low matured. The low has a negative effect. يعني, if we increase the erosion depth, it has a negative effect on the maturity. It's different from the lithology effect. Okay, so the if we make an enter an erosion thickness and increasing the erosion thickness, we will have an effect on the maturation. Low amount of effect, low amount of erosion, low amount of decreasing in maturity. High amount of erosion, it increase the effect of decreasing maturity on the that's in vitrinite reflectance. And also we say that we can observe that the same effect on temperature maturity curve. Also, with a low amount of erosion, it's not a high amount of decreasing in maturity. But if we decrease, so we can it's a little effect the erosion. If we increase the depth of erosion or thickness of erosion on the model, it has maybe less effect of decreasing of maturity on temperature. Also, the heat flow. If we didn't determine accurately the heat flow of the basin and type any hazard data, we can't get an accurate model. Absolutely. It's an example of entering a heat flow like 29 here. We can say that the model is a good matching between temperature maturity curve and the vitrinite maturity curve. And after that, after we editing and change this number from 29 to 55 and increasing the heat flow at the zero at depth or age of 21, we can observe a great difference in maturity. The increasing of heat flow, increasing the maturity profile curve, and we can see and observe a great difference between the modeled data and the measured data, as we see in temperature and also in vitrinite reflectance. So the calibration it will be good, and we need to spend more time in calibration of the model. Thanks. Asking questions.
Thank you, Dr. Tamer, for your interesting session. Actually, many of the new information was delivered during this session, so I would like to thank you again.
Okay, thanks, Mr.
Thank you. So, just I want to try, I would like to inform the participants that if they have any questions, they can type them into the Zoom chat. So, Dr. Tamer, we have some questions. We have a question that what are the elements that determine the quality of oil and the time of beside the type of the organic matter.
Okay, can you ask again, Mr. Abdullah? I didn't hear you well.
Okay, what are the elements that
Elements, yeah.
determine determine the quality of oil besides the type of organic matter?
Yeah, okay. Yeah, this is a good question. We can say that first, it is a type of kerosene from itself, from the first, the type of kerosene and the quality of kerosene. If the type of kerosene, we have a different types of kerosene. Type one, which is marine deposition environment, which generate oil prone. And type 2, it's no, type 2 and type 3. So it's firstly, the type of kerosene has an great effect on the quality of petroleum and the quality of petroleum and the type of generated hydrocarbon. Okay, so we can, based on the type of kerosene, we can get oil, we can get gas, or we can get a mix of oil and gas. Type of oil also, the type of the deposition in the deposition environment, which is maybe high sulfur content, rich with high sulfur content, so it will be effect on the amount, the quality of oil. So, firstly, the deposition environment and the chemical composition of kerosene has a great effect on the quality and the type of oil.
Okay, thank
Did
you.
I answer your question?
I hope so. Okay, so another question. What are uncertainties in the Basin model and how can be minimized?
Yeah, okay. We have great uncertainty in our Basin model. Especially, we need to focus what is the difference between the present day and the paleo tectonic and the difference between the present day tectonic setting and the paleo setting. Okay, so we need to calibrate this model, to calibrate the model by accurate determining the accurate, firstly accurate explaining and understanding the what are our the basin, and what are the most geological settings, and what are the most geological structural tectonic settings that affecting our basin. Okay, and what are the depths of basement, and how much amount of heat temperature that coming from our basin modeling, from our heat. Okay, that determine the maturity indicator. Also, if we accurately determine the how much the heat flow is coming from the basal heat flow. Okay, and also determine the depth of valley water depths, that where the our layer of source rock is deposited. And after that,
Okay,
using all the determining the accurately the age and the positional setting and the positional environment, and also the lithology, as we said in the calibrating the model. The lithology has a great effect on the maturity, and also if we use the different heat flow from the accurate heat flow, and also the surface water interface temperature of our source rock. All of these data making an uncertainty, so we need to accurately determine and use thermal conductivity, thermal bottom hole temperature. Every step has uncertainty and should be calibrated and validated to get accurate model. As you know, robust input, we will have an accurate model.
Okay, okay. Another question. How can we know if hydrocarbons are remigrated from one system to another?
Yes. Remigrated hydrocarbon, we can know that if we make as the geochemical study, including the we can study the basin modeling, making an oil source correlation and oil gas correlation. We can say that if we need to study a basin, okay, we can determine all of the source rock that penetrated in this basin, determine the source rock and type of corrosion and the type of hydrocarbons that will be generated if it generated. So we have record of all of our source rock. So if use the and also study the reservoir rocks, of the reservoir and the hydrocarbon accumulated in the reservoir, and making oil source correlation, we can say that this source rock, this oil came from the source rock number X, and deposit in reservoir rocks. If it is the same correlation between the source rock and the oil that found in the reservoir rocks, we can say that it's only migrated first one, yeah, not remigrated. But if the oil hydrocarbons that accumulate in reservoir is enriched with other parameters or other any composition, it might be coming from another source rock or coming from trap. Okay, we can say that it's remigrate.
Okay, thank you. Just the last question for the time for our session. What is the boundary condition and what is its impact for the basin model?
Yes. That's the boundary condition in the geochemical evaluation. As we said, the boundary condition, we have three boundary conditions. The first one is the heat flow. It's a boundary between boundary. It's we need to accurate the heat flow firstly to can determine accurately how much temperature are coming from the heat flow and affecting on our source rock. Okay, this is the first one. The second one is the paleo water depths. As we said, we need to accurately determine the water depths, the water depths maps, and what is the depths that the source rock are deposited, where deposited at the where deposited. Okay, what is the depth and what is the temperature of the surface of the basin while the our source rock are deposited. Okay, and the third one is the surface water, surface water interface temperature, heat flow, and paleo water depth. So this boundary condition.
Okay,
So,
okay.
as we said, that all of them has have a great effect on the maturity and validation of the model. If we use an accurate data, it will be has a great effect on our model, and we will not get accurate model.
Okay. So thank you, Mr. Tamer, for your time. Actually, we received a lot of questions from the participants. However, I assume that we don't have a great time for answering all the questions. So again, if for the participants, if they still have some other questions, we encourage them to send these questions to Reservoir Solutions contacts, and we will do our best to answer
It's,
them as soon as possible, inshallah.
it's
So
our
thank you,
pleasure.
Mr. Tamer. Thank you. Thank you again.
It's our pleasure
Uh,
to have any question from all of the audience in any time.
okay, thank you. Thank
Yeah,
you, Dr.
thank you.
Tam, for your time and effort to enrich the information into this session. Also, I
Thank you.
would like to thank everyone that attending this session for their time and enthusiasm to get new information and for learning. Also, we would like to remind everyone that if you wanted to get a certificate for attendance for this session, you can fill into the form that was sent into the Zoom chat. Also, I would like to remind them that we will have workshops into the upcoming days. We have the first workshop that will be at 20 at the 1st of July for reservoir characterization using well logs and core data integration, the routine core analysis and the special core analysis. In this workshop, we will learn analysis, how testing for the data for reservoir simulation, the routine core analysis, and the special core analysis. We will learn analysis, how testing for the data for reservoir simulation and reservoir modeling, like the rock typing, the separation height modeling, and so on. How we can interpret the special core analysis. All of this stuff it will be handled onto a software during this 5 days workshop, and we will have, and if your time is not the best, so we will send the recording for the sessions for this workshop, and the advantage is that you will have lifetime access to the recorded sessions. We will have application datasets to make the workshop is practical. Also, you will have all the course material. It will be provided. You will have open discussion with the instructor during the workshop and after the workshop. So don't worry if you have any question after the session or after the workshop. You will have a course WhatsApp group to exchange the questions with the instructor even after the course. And after the workshop, you will have a certificate with online identification ID on Reservoir Solutions website. Also, the other good news is that we will have a workshop for Bayesian modeling and applied geochemistry. Into this workshop, it will be also 5 days, about 3 hours per day. And also, this workshop is a software based, so we will have a lot of information that we deliver during this workshop. We will know what is the petroleum system, how we can do modeling for for the basin, how we can do all this stuff that's required for basin modeling and the applied geochemistry applied also into a software, and we will have a dataset for application. You will have also lifetime access to the recorded sessions, application dataset, the course material is provided. You will have open discussion with the instructor during and after the workshop. Also, you will have a certificate with online identification ID on Reservoir Solutions company website. So I think that is all, and it's time to end our session. So we will have 5 minutes. I will share now the link for the webinar, the webinar certification. If you want to get a certificate for attendance for this webinar, I will share it now to the Zoom chat. Also, I will share the registration links and the details for this workshop into the Zoom chat. After 5 minutes, this room it will be closed, and we hope that you enjoyed this session. So, hope you good night and assalam.
Thank you so much. Okay. Thank you.